Okay, so this is our data we want to interpolate between. The numbers don't matter, the principle's the same. So what we're trying to do is we're trying to create an imaginary line, a better line than that, between these two, like that. So how we do that is we say we want to figure out how much it changes vertically for how much it changes horizontally. So we say the delta y over delta x, and in this case that would be 30 minus 12 over 10 minus 5. And what that gives us is whatever that number is, which I'll work out just so we know, over 10 minus 5 is 18 over 5, or 3.6. So that means when x goes from 5 to 6, that increases by 1. It means y increases by 3.6. So it's 3.6 more. So that point there is 15.6. So we've got our change per step. But then say we want to work out this point here. Let's say this is 0.8 on the x-axis. We need to know how many steps along we need to go. Because if we take 4 steps, then y will increase by 4 steps as well. So we have to multiply this by 8 minus 5. And that gives us, obviously, 3. So there's too many steps here. Ignore that. Yeah, so that means we've gone up 3 steps here as well. But what we've defined is we've defined this line between here and here. So we have this, but that's not what we want. We want this line all the way to the origin. So what we have to do is we have to add on the initial value of y, because we've calculated this difference here. This bit here gives us this value. We need to calculate the rest of this. So we add on the lower value of y, which is 12. So then we can say times that by 8 minus 5, and then add 12, and we get our linearly interpolated point is 22.8. So we start again, dy by dx, or delta y by delta x. That gives us how much y changes for every unit of x. And then we see how much x we need, which is we take away, so how far along x are we from the starting point of our imaginary line. And then we have to, when we know that,